Okay, I know that 9.3 section was really, really long, but it was really pivotal because if you kind of understand what we were doing in 9.3 and how confidence intervals work, it really helps you through the rest of the chapter. All right, now we're going to do 9.2, and I know it seems like we're going backwards, but not really. 9.3 is kind of a good foundational one because all the polls and surveys in the world work that way, and it works off of the normal curve. That's why you had, hold on, Z. See how Z is in that? That's because it's normal. So you were able to use the power of the normal curve. Now, in this section, we have a little bit of a trouble. All right, so the FBI compiles data on robbery and property crimes and publishes the information. A simple random sample of pickpocket offenses yields the losses in dollars shown below. So there. Obtain a point estimate for the average loss in dollars. Now let's just think about this. Oh, of all pickpocket offenses. Excuse me, I didn't finish my sentence. So they want us to estimate, matter of fact, let me put it this way. Estimate, and I'm not even going to bother with, I'll just do this. Estimate mu, right? Isn't that what they want? I mean, if you're talking about the average for all offenses, right? The point estimate is the best guess for mu. Well, what would that be? That would be X bar, right? I mean, haven't we learned from chapter 3 onward that the sample mean would be the best guess for the mean? The population mean, excuse me. Now, could we find it? Well, sure we could, especially if we typed all that data in our Excel, which, lo and behold, I already have. So let's find X bar. X bar would be the sample mean, which is equal to average of A2 colon A26. It's just easier to type it. So it's 513.32. Going back. Equals 513.32. I really don't want that to be so large anymore. There we go. Okay, cool. Next, so we want to make a confidence interval for the average because, I mean, let's face it. We know that the pickpocket offenses average overall for all of U.S. is not $513.32 exactly. That's not how it works, right? We know it should be close to 513. Now let's remind ourselves, what did we learn about X bar and how it is spread out? Well, in section 8.1, we learned that it had a normal distribution with mean of X bar equal to the mean of the population, right? And the standard deviation of the sampling distribution equal to sigma divided by the square root of n. Right? Right. So if we want to use X bar to estimate mu, right? Because that's the best guess. But what could we do to estimate sigma? We don't have sigma. I mean, if we had sigma, sigma is the population standard deviation. If we had that, we would have it for the population mean, and we wouldn't have to bother with any of this stuff. If we knew the population mean, we'd be done, right? So our answer is S. The sample standard deviation. All right, sample standard deviation, that's your best guess for what you get. Okay. The problem with that is that if we do this, if we use S instead of sigma, while it's good, it does create some problems. It's not quite perfect. It doesn't quite give us the normal curve anymore. It gives us a curve that a man named William Seeley Gossett found. He was a guy that was working for the Guinness Brewery in Dublin, and he devised something called the T distribution. And he figured that's how S would work. S and X bar work in tandem in the T distribution way, not the normal distribution, where N has T distribution, excuse me, has N minus 1 degrees of freedom. All right, so let's talk about that in the next one. Hold on one second, and I'll see you in the next video.